Okay, now that you guys have watched the first video, let's go ahead and talk about some examples of which one is acid, which one is not acid. So if we're given the question, which of the following compounds cannot behave as an acid based on the structure? We have A, HCl, B, HNO3, CH4, D, H2SO4. Okay, let's just go ahead and get a quick refresher. Remember that acids form covalent compounds, which covalent compounds is equal to two nonmetals bonding together. And the reason why acids need this is because that's the only way they can go ahead and ionize in water and release the H plus ion. So before we go ahead and check what is the acid and what is not, let's go ahead and see if all of these are covalent compounds. We can go ahead and see HCl. This is all made of nonmetals. Notice that B, over here we have a polyatomic ion. That doesn't really matter because this compound is still made up of all nonmetals. So this is also a covalent compound. Next we have CH4. This one is also made of nonmetals, which means it is also a covalent compound. Can you guess if this is a covalent compound? This one will also be a covalent compound, even though it has polyatomic ion right here. Okay, now that we got that out of the way, and all of these are covalent compounds, and we know what we're looking at, let's go through every single option choice and see which one will behave like acid and which one will not. At the end, I'll give you guys a quick trick on how you guys could have done this problem really quickly. Okay, so for the first one, we have hydrogen bonded directly to a chlorine, which means it's extremely electronegative, which means that this can go ahead and allow the hydrogen to release in water, which will form us an H+. Now, if this hydrogen goes out and we get an H+, that's a property of an acid. So A will be an option choice. Okay, how about B? In B, we see that we have hydrogen and oxygen together. This is part of the oxygen-hydrogen group. Because oxygen is also very electronegative, this will also allow this hydrogen in the compound to dissociate and become an H+, which means this will also be an option. Okay, how about CH4? Now remember, carbon, it has only 4 valence electrons. Because it only has 4 valence electrons, that means it's going to be less electronegative, which means we won't see that the same dissociation as we saw in the first two of the H+ getting released, which means option C is not an acid. Okay, let's check D. Now we do know that we have the answer ready, but let's just make sure D is not also another answer. There might be two answers. Okay, so for option D, we go ahead and we actually see this hydrogen and oxygen bond again. And because oxygen is very electronegative, that means in water, it will allow the hydrogen to dissociate and become a H+, which means this will also be acid. So the only option that's correct is going to be C. Okay, let's go ahead and erase all this and go and see what's another method we could have solved this problem within 1 second. Okay, remember, if we have hydrogen at the start of the compound, then we can very quickly identify if it's acid or not. Although there's two exceptions. And the first one is if it's a positive amine, the second one is if it's acetic acid. These two don't actually apply to any of these examples. If you guys don't remember what a positive amine or a acetic acid is, go and check out the last video, which is Introduction to Acids. In that video, we went ahead and talked about what are positive amines and the two different forms acetic acid is written in. For this example, we don't have to worry about this because I already identified in these 4 examples, we don't have any of these. Okay, so H at the start of the compound. That's pretty simple. This one has H, this one has H, this one has H. This is the only one that doesn't have H, so this will be our answer. Hope this video helped. Go and check out the next video where we are going to go ahead and talk about the properties of acid, as well as how they behave.